Alrighty, this is lesson 4-2. It's all about angles and angle bisectors. Our learning targets, what we're supposed to accomplish, or what we're supposed to know after this is all said and done, is we need to apply the angle addition postulate to find angle measures. So remember, just a postulate, what that is just a statement that does not need a proof. It is accepted without proof. We know it's true. And we're also going to use the definition of angle bisector. We already know what a bisector is from the previous lesson, so we're just going to apply that concept to angles. That's going to help us find angle measures in certain situations. Here we go. It says you measure angles with a protractor. We've done that before. We did that in the getting ready for unit 1. We use that protractor, and sometimes it's necessary to before you measure, sometimes you're going to have to extend those rays so you can get a more accurate reading. Because for my protractor, I can't see exactly where ray OC goes. So if I wanted to use this larger protractor, I would have to extend these rays. It says the number of degrees in an angle is called its measure. Where degrees comes from is the astronomer Claudius Ptolemy, I believe is how you pronounce it. But he based his observations of the solar system on a unit that resulted from dividing the distance around the circle into 360 parts, and so it later became to know as a degree. So think Sir Claudius for degrees, for that unit of measure. We're talking about angles. So here for item 1, it asks us to determine the measure of each angle. So for part A, it gave us that we're supposed to find the measure of angle AOB. Quick review about angles and the appropriate notation. If I had some angle, let's call it angle XAZ. When I want to refer to the actual object, I would use this notation, angle XAZ. We also know it's the same thing as angle ZAX, and in this case we can also call this angle A because it's an isolated angle. But when you want to refer to its measurements, you need to add an M in front of it, that lowercase cursive m. And this is talking about some numerical value. So the measure of angle XAZ, that's some numerical value in degrees. Or if we want to talk about the measure of angle ZAX and the measure of angle A. What this allows us to do, this notation, allows us to set up equations. And so since we know that these are just the same angle, just different names, we could set these equal to each other and say that the measure of angle XAZ is equal to the measure of angle ZAX. So when we're looking here, for part A, they asked us to find the measure of angle AOB. That's this guy right here. And so it's here at 0, so we're going to use the inner set of numbers, and we would just count up to 10, 20, 30, 40, and it's sitting there right at 50 degrees. Don't ever forget your units, that degree symbol. Item B says the measure of the angle BOC. So BOC is right there. Well, it starts at 50, and then it goes up to 60, 70, 80, 90, so that those two rays are separated by 40 degrees. If you take 90 minus 50, that's going to give you 40. And don't forget, when we're talking about measurement, it's the absolute value of the difference. And that's exactly how the ruler worked. That's the ruler postulate. Well, it's the same thing with over here, the protractor postulate. They're very, very similar, the ruler postulate and the protractor postulate. Part A says, to each angle there corresponds a unique real number between 0 and 180 degrees called the measure of the angle. Pretty obvious. And then part B says the measure of an angle formed by a pair of rays, those are the two sides, is the absolute value of the difference of their associated numbers. So we're taking the absolute value of 90 minus 50 equals 40. Another way of writing that is the absolute value of 50 minus 90, doesn't matter what order you put it in, because even though we get a negative value, we're taking the absolute value of that, and so that will be 40. Moving on, we got the measure of angle AOC. Starts here at 0, goes all the way up to 90, so that one would be 90 degrees. EOD, so now we're coming over here on the left-hand side of the protractor. EOD, this is separated by 10, 20, 30 degrees. And the measure of angle BOD, this ray is at 30 degrees, ray OD, and then it goes all the way over here. Ray OB hits at 130. So the absolute value of this difference would equal to 100 degrees. And the last one, angle BOE. If we start here at 0, use our outer set numbers, it goes all the way to 130 degrees. Item 2 asks you to use a protractor to determine the measure of each angle. If you don't have one at home, that's okay. I highly suggest that you get your own to practice. But this is an example where at the beginning of this video I said that we're probably going to have to extend these lines because I can't see where that intersects with these two sets of numbers. To get an accurate reading, I need to extend these lines. And so when I do that, I can extend it out here. I'll extend this bottom ray QR as well, so now I can get a very accurate reading. Put your vertex in, for this protractor, you put the vertex right there in the center of that hole, and then I'm going to start here at 0, count 10, 20, 30, 40, all the way, looks to be about 139. It's not exactly, it's not quite to 140 yet, so we're going to call this 139. So I've already filled them out for you. This one's 115, this one's 24, this one's 139 degrees. But it's good practice. Make sure that you get those values when you practice with your protractor. Item 3 says, using your results from items 1 and 2, describe any patterns that you notice. Well, this is the exact same pattern that the segments had, that when you have an angle with a point in the interior and you can create that, that third ray, there's a total of 1, 2, 3 angles in this diagram. You have the two parts and then the whole. And so just like those segments, we notice that part plus part is going to equal the whole. We're talking about these measurements. When you take the measurement of the two parts, it's going to equal the measure of the whole angle. Item 4 says, given that point D is in the interior of angle ABC, so let's go ahead and draw a diagram. I have some pre-made, so you can just pause the video and create your own diagrams. So I have angle ABC. It says that point D is in the interior of that. Remember that the interior is that space in between the two sides. It's the space in between the two rays. So it doesn't tell us exactly where it is, so I'm just going to make sure that it is clearly in the interior. I'm going to connect the vertex of that angle, angle B. I'm going to make a ray that goes through that point D. So now in this diagram I have 3 angles. I have angle ABD, I have angle DBC, and I have the whole thing, angle ABC. It says describe how to determine the measure of angle ABC, so that's the whole thing, without measuring it. Okay, so we can't use our protractor. So how would we find the measurement of the whole thing without actually measuring it with a protractor if we are given the measures of angle ABD, which is one part of the whole, and then angle DBC, which is the other part of the whole. And it's simply add parts. The parts will sum up to equal the whole. And it says in item 4, in your answer together, form a statement of the angle addition postulates. And that is just when you take the two parts and sum them together, when you take the two measures and sum them together, it's going to equal the measure of the entire, the whole angle. Part plus part equals whole, just like segments. Moving on. In all honesty, that is a huge chunk of this lesson is the fact that you're going to have these whole angles, these diagrams that I've already made. You're going to have these whole angles. You're going to have some point that's in the interior for every single one of them. And you're going to divide this whole angle into two parts. And don't make it any more difficult than it needs to be. It is simply part plus part equals whole. So I suggest that you try item 5, all parts, on your own. Go ahead and pause the video, work them out, draw diagrams. Remember those 4 steps when we're solving these? Step 1 is always draw a diagram. Item 2, or the second thing that you do is label your diagram. Put the points in, put the measurements in, everything that you know about it. Label everything that you know about that diagram. Number 3, you want to write your equation. So sometimes that's part plus part equals whole. Sometimes if you know that segment or angle is being bisected, you set the 2 parts equal to each other. It just kind of depends on the information you're given. After you write your equation, substitute, sub in values. Those are the expressions. And then 5 is just solve that equation. But these 2 points, these 2 steps, 1 and 2, are so crucial. In this book, it says, hey, that's a tip. I suggest that you draw a diagram. No, I'm going to say that it's a mandate. You need to draw a diagram. You need to label that diagram. And then from that, write your equation, plug in your values, and solve. So again, pause it, try them on your own, and then you can check your answers. So for part A, it says if point P is in the interior of angle XYZ, so I have angle XYZ over here, it tells you that point P is in the interior. So I'm going to go ahead and draw that ray. So now angle XYZ is broken up into 2 parts. It says that the measure of angle XYP is 25 degrees, and the measure of angle PYZ is 50 degrees. So then the measure of angle XYZ, the whole thing, has got to equal what? Well, I've drawn my diagram, I labeled it, let's write an equation. The equation is, or would be, the measure of angle XYP plus the measure of angle PYZ. I'm running out of room. But when you sum this, it's going to equal the whole. So that's the measure of angle XYZ. So part plus part equals whole. And then you just sub in your values. I don't know the measure of angle XYZ, but I do know these 2 values. That's 25 and 50. So when I solve this equation, the measure of angle XYZ has got to be 75 degrees. Part plus part equals whole. Part B, it says the angle, excuse me, angle, I'm sorry, I was trying to figure out what diagram. Okay, here we go. I got it. This diagram over here. If M is in the interior of angle RTD, so this point is M, so I'm going to go ahead and cut this one angle into 2 parts. It says the measure of angle RTM, so this guy, is 40 degrees. I'm labeling my diagram after I've drawn it. The measure of angle RTD, so that happens to be the entire thing. So I'm going to kind of make this motion just indicate that this is the whole thing. 65 degrees. Then find the measure of angle MTD. So I'm going to go, I've got my diagram, I've labeled it, now it's time to write an equation.